Hello, did that work? Yeah, let's go. Alright, hello guys, Josh here, back for another computer science and math stream. I think I've got chat. Yes, that should be good. And I guess we can begin. So, how long have I got? I've got like 30 minutes or so. So at the moment we're on a series thing. Yo, I should have the thing from the previous one, do I? I did one about graphs very recently. Oh no, am I throwing here? Oh, most definitely, this is great. Question is, can I get to the thing I need? That much difficulty. Oh no. One sec, I need to find this, one sec. Let's just put the music back. I didn't close it, did I? Yes. Okay, all is good. Alright, let me just find the file. I can't find it at all. Oh well. So essentially last time we looked at graphs, which is, just to recap, it's where you have your nodes and it's like, whoa, these two nodes are connected, and they can either be connected like this with no direction associated, so it could be this way, or it could be this way, or it could be both ways at once, but instead of drawing it both ways at once, we just don't put an arrow at all. So this would be considered a bidirectional edge, no, bidirectional relation, because it can go either way. Whereas here we could say it's directed, and it's like it can't go either way, it's only going that way. So those are graphs, it's what was looked at last time. We'll just put a label on it. Oh wow, that's small, oh well. And today we're going to be looking at so-called functional entities. So, wait, have I made myself mute? Am I doing bad things? No, I'm loud, that's good. That's good. Let's make this a bit bigger. Oh, let's go. So essentially, what a functional entity is we're just going to be using that graph idea. Oh, and we're on part fundamentals of imperative programming 2 of 5. Wow, it's huge. Let's go right there. So the first one's graphs, then after graphs we're doing this one on functional entities, then we're going to be looking at fundamentals of imperative programming, then we're going to do procedural programming, then after that we're going to do object-oriented programming. So those are the 5. We've done graphs, we're on this one today. And essentially with this whole series, I wanted to like describe object-oriented programming in like 3 or 4 minutes. Wait, I'm so worried I put it on the wrong one. No, I am on the right one. It's all good. But essentially, I just wanted to explain object-oriented programming in 4 minutes. But then I realized you need all this extra pre-knowledge before object-oriented programming makes any sense. So we're just going through all of them. We've done graphs, and now we're going to build a bit on graphs. We're going to build on graphs throughout, but this is the first like usage of graphs that are really important, is a functional entity. So what a functional entity is, you have three nodes, three entities, three things, and you have relations between this node and this node, which we could call A and B for now. We've got another relation between B and C, and they're not bidirectional, they're directed. So we've got A into B and then B into C. But these aren't any old nodes, these are actually really important. These are called, got our input node or in node, we've got our logic node, and we've got our output node. And this is where we start to see like the bare roots and the bare bones of computer science, which is what sort of we're going to build on moving forwards from here. So this might not seem particularly interesting at first, but essentially the idea is that anything within computer science pretty much can be modeled as a functional entity, and that's pretty much the fundamentals of all of programming, is that every single component of the things you build on a computer will be a functional entity. That includes the computer itself. So with a computer, for example, you may have heard of this, you may not, but you have input-output devices. So with a computer, you have monitor, you have keyboard, and you have a mouse. These would all be considered, actually we've got a few different ones. We've got our input here, this will be our input node, which I'll just denote I, and then we've got our monitor output node, which put an O, and then we've got the computer itself, which is like the logic one. So the computer itself is a functional entity, but everything inside the computer is a functional entity. And so essentially you can bring them together. So like if you have two functional entities next to each other, they can essentially like work into each other. So I'll explain what I mean by that. This is our in, our out of this functional entity. I don't think functional entity is like a proper phrase, but I think it's an important one to like, this is what I would call it. And this model gets thrown around a lot because it's really important. And essentially, any two functional entities can interact this way. So it goes into one logic, output into the other. And actually, a computer and a human do this all the time, which is where this model gets really powerful. Well, it's one of the most like commonly used one that's really important. So for example, for your input, you'll have your eyes. And then for your logic, you've got your brain. And then for your output, you've got like hands, I guess. And one, you've also got your mouth and stuff like that. And then we've looked at input and output of a computer. So you've got like your mouse and your keyboard, and output the monitor. And essentially, you and the computer are forever like working as two functional entities connecting. But you can like make the system more complicated. So if we stop drawing a functional entity as three nodes and just one node, you can like imagine the in and out nodes connecting up between a bunch of them, so that you have like a network of things going on. You have things happening. And that's essentially all there is to functional entities. So that could be the end of the video. I'm just looking at chat, sorry. No chat. Oh no, I have got chat. Yo! Yo, hey Noah. Welcome to the stream. Just discussing functional entities, whoa, which is really important for programming. Like, essentially, this is the building blocks for all programming. So I guess I've sort of given the example of a computer, a human, but I guess to really get into just how important this is, and this is going to be important for both procedural and object-oriented programming. And by the way, procedural is that type of programming everyone goes on about. Like when people are like, I want to learn programming, I want to learn the basics of programs rapidly, they're talking about the procedural paradigm within programming, because that's the one everyone always talks about to begin with. But there's actually a bunch of different paradigms, which when you get into computer science, you start to really care about. So there's 5 main ones. So you have assembly, or ASM, or sometimes called machine code, as like this is sort of where we started. When we first had computers, you only had this paradigm, and it meant essentially you would like codes in ones and zeros. So like you literally this would be code, right? Which is like, bruh. It's like code now is like this, so it's like there's actual words here. So like we can see data here, we can see getter, like there's words here that you can recognize, but like machine code paradigm, it's literally ones and zeros. But to make it a bit easier, they had like, let's do address 05 output. Oh, that's whole. So what you can do is you can convert it into these. So essentially, how many ones and zeros have we got? 4, 4, 4. So like we could say these sections are this statement here. So even though fundamentally it's still just ones and zeros, it can make it a bit easier by putting words to each section of ones and zeros. But really, you're just coding in individual single instructions. Binary let's go, yeah, that's a paradigm, but it's not a very useful one because it's darn difficult to use, so not many people use it. You'll use it sometimes, but not so much. But what you use a heck of a lot of is you'll use procedural a lot. Object-oriented is fun, but kind of frowned upon because of the problems it can cause. And over here we have functional. There's 5 of them. I got logic. So these are like the 5 main paradigms. I guess there's other paradigms too, but essentially these are the main ones. And a paradigm is just a way of programming. So the programming you see here is procedural, but also a bit of object-oriented, because we see this keyword class means that we're dealing with the template for an object, which we'll look at later on in the series, the 5th episode. But a paradigm is just a way of programming, and the one which most people talk about when they talk about programming is the procedural one. So these two here, why am I writing? It's way easier just to type. And we'll do it a fancy color because we're fancy. Oh, I didn't do anything. Oh, there we go. Does the orange look any good? No, it's probably invisible. Oh, is it too small? Oh, these are the many problems. Alright, let's go big red. Oh, let's go. No, wait, this is imperative. What am I doing? Got our imperatives here, which is the procedural and object-oriented, and we got our declaratives here. So declaratives are insane. We're not going to be going to declaratives for a long time, especially like functional programming, because that's essentially like Lambda calculus, which is fun, but like mind-numbingly complex and difficult to think about. But then on this side, we've got things that are a lot more manageable. Procedural and object-oriented. Object-oriented is more of a headache, and procedural is more what people talk about. But object-oriented is not too bad, and it's what we're going to be doing episode 5. But for now, we're just looking at functional entities. And within that, I thought it'd be good to give an example. Essentially, this diagram here is the entirety of what I want to talk about. That is a functional entity. You take something in, you think about it, and then, or you do logic on it, and then you put something out. And humans are logical entities, lots of things logical entities. Essentially, if you say something can be functional, it's a logical entity. It's a functional entity, sorry. So like, the door is a functional entity because if I put an input, if I push on the door, or I pull on the door, there's the mechanics within the door, and then either the door will open or not, depending on if I'm pushing or pulling the right way or whatever. But this is the video, but I guess it'd be good to give an example, so I thought I'd dissect some of my previous code, have a look into this. This is What the Tinker, a video game I worked on. I guess I was like, is this a good example? Wait, does this not? Yo. Oh, because it's an object. Okay. Okay, no, this is good, this is good. We can look at check gravity. So this is a functional entity because pretty much everything within a computer is. But specifically, if you have define, that means it's a function. And that's like definitely a functional entity. If it's a function, it's like, that's the key characteristic of functional entity, is that it's a function, basically. I don't know if that made any sense, but that's fine. Let's have a look into the game, run the program. Ooh. Oh wow, how long is it going to take to load for a computer dying out on me? Oh no. Bruh. What's it trying to do? Why is that not working? That's unusual. I was thinking there's no way it won't run. I don't want to load PyCharm, because PyCharm might actually kill my computer. Oh, that is a problem. It's not running though. Heck, have I got a compiled version I can just run? Please say I have a compiled version. Yeah, this is an L. I 100% agree. But I might be able to pull this back because I might have a pre-compiled version. If I do, that'll be such a gamer moment. Do I? Is it in the backups folder? Yeah, Python's such a bright moment. I agree. Oh, exports, come on. Please. No, I don't see any compiled. No. Yo, is that compiled? It's not. Oh no. Why can I find a compiled version? In the final? Oh no. Probably just search. Hey, that's compiled. Does it work? Please work. If this works, it's going to be such a gamer moment. Oh my goodness, well, it's not crashed yet. Let's go! That's a W. That's a W right there. That's a gamer moment. Alright, so this is a video game. As you can see. That should push my my viewer rating though. Was that loud? Oh, amazing. So, oh, I have to do some gameplay before I can do stuff. How long do I have to go? All right, let's go. This is a video game. Okay, and look. So basically the idea of this video game is every time, so you can see it's tile based. We move around. This is going to make my videos amazing. I actually have visuals for the first time forever. It's not just raw code. I should do a playthrough of this game, I'm telling you. But anyway, so essentially we've got a grid-based thing, and we move around. Wait, how loud is the game audio actually? Oh, I'm probably being drowned out right now. Let's put that right down. There we go. Still kind of loud. Oh, that's okay. And essentially, right now, when I walk, I should fall because there's nothing below me, right? So, oh, I wish there was a pause button. There isn't a pause button. Is there a pause button? No, there isn't. How loud is it? Oh, I can just turn the... Oh, I can turn my volume down. Bro, using a computer's hard. Studying computers not too bad. Using one, oh dear. Alright. So essentially, oh, I could turn volume off. Let's turn the volume off. So essentially, we need to be able to check what's below. This bot's called Tinker, the robot here. So we can write a functional entity to do so. So here's a functional entity here with identifier check gravity. Can't even hear it. Put the volume back up. Oh no, yeah, I was just trying to pause the audio basically because I was more worried about it drowning me out than anything else. So we've got a functional entity here called check gravity, and we can draw this functional entity. That might be a good idea. Good exercise. Oh, and it's red. Fantastic. I can't have that. I need the space. White looks like it has more space because color theory and stuff. Alright, so we have functional entity, check gravity. Let's go. It's bold. Let's make it big. Here it is. And essentially, the rough outline of its structure is it will do input, logic, output. We're aware of that, but let's look at what those inputs, logics, and outputs are. You want to hear the game music? Fine. Fine, I'll give you some game music. This might be blastingly loud. How loud is that? I didn't make this music. This is just ripped straight from another game called Tinker. Microsoft Tinker. I'm probably being drowned out right now by the music. Is this enough music yet? You can play the game. I can send you a copy of the game. This is what I did over the summer. It was great. You probably can't hear me at all. Alright. Enough of that. Happy? I don't know. How to get watch time. Make the audience happy. Alright, so let's look at what this thing does. So I guess we can, as we said, this is the input. This is the logic, this is the output, and we can like split a program up into each of its parts, which is a really good practice to do, by the way. Split a program up into its input, logic, output. Input, logic, output. And then let's have a look at what's going on with our check gravity logical entity, functional entity, because basically I just want to show that functional entities like are a real thing. Yeah, the game, that's why I didn't want to make it loud before, but now you know what it sounds like. Not particularly interesting, but there you go. But yeah, I just want to show this isn't just theoretical. This is like when you're programming, you will use this model over and over and over again. So check gravity, what's it taking in? It doesn't take any things here, but like imagine it does. Basically, because it's object oriented, these things should be passed in, but they're not because object oriented is weird. But you can imagine it's passing it in. It essentially is. So it's passing in that. Is it just passing in that? Oh, and level data. Self.level data. So these would be considered our inputs. So we're defining a functional entity called check gravity, and we're setting up what things we need to input to check gravity, and then this is our output here where it's giving us some information. So our inputs here are player position, in other words, where is the player on the game board. So if the player's over here, that would return a tuple 0, 0, 0. Let me explain what tuple is. If we were there, then it would be returning a tuple. A tuple looks like this. It's essentially like, you might have called these a set, or you might call it a list or a collection or whatever, but essentially you've got three numbers grouped together into a single thing. And in computer science, we call it either a tuple or a list, depending on the context. Here, because we don't want to change how many items are in the... Wait, did I do it as a tuple? I don't think I did. We can find out. We'll look at the code. Oh no, we did it as a dictionary. That's fair enough. Dictionaries are a good idea. So essentially a dictionary is where it's... Well, that means we need to change how I've drawn it. I haven't muted myself, have I? That'd be bad. Nope. Also got to make sure I don't stream too long, because this is a really simple idea. I shouldn't be streaming too long on this idea. Oh well. Maybe people got something out of programming from it. If not, it's fine too. Functional entity is important though, so I don't mind spending a bit of time. So essentially I did it like this. So it's a dictionary, meaning each number is corresponding to a value. So here it's at 0, 0, 0, but let's say this was... I think when I program this is the z direction. Then this would be now 0, 0, 1. So it's basically just coordinates. So we need to pass in where the player is our first input. Oh, I should actually copy the inputs in. Wait, I should make it consist. No, I don't really care. No, I do care. No, I don't care. Let's make it consistent like that. No, it's confusing. No. Yeah, like that. So those are our inputs. We're putting in where the player is, and we're putting level data as what is the level. So the computer's being told, sorry, the functional entity check gravity is being told that player's here and the level is like this. And what it does is the logic section is all of this, I guess the code, but the inputs and the outputs is also code. This is code, and this is code. But as you can see, and this usually happens with functional entities, the logic takes up the vast majority of the code there. So you can see like just this and just this are the input and output. All of this is logic. All right, let's go back onto the paint. So that's our logic. We could break down the logic if we wanted, but essentially what we're doing is we're creating some reference values here where we're saying we're going to create a reference, and we're creating the reference at the same position as the player at X, same position as the player as Y, but Y minus 1. So essentially if this is the player here, draw the player. This is the Y dimension. We're essentially creating a reference below the player here. Essentially we're saying this is our point of interest, one block below the player. So we set that up here, and then this is just a technical detail, which is complicated to go into. That's because of the graphics renderer, it needs that attribute, but that's confusing to think about. And then we use the reference, and we formalize the reference here and say that the reference is called. So before the reference is this, but now it's got a name. The name is block below chords. And by the way, if like this is only if you want an example, like honestly, as I was saying, the only thing that's needed for the rest of this series on object-oriented programming and procedural programming is that diagram. Like this is literally, this is just if you want an example of that in use. So this is an example of that. You'd split it up into input, logic, output. So we create a reference block below coordinates. It's the block below the player. And what we're going to do is we're taking the block below. This is just error handling. This is just technical stuff too. We don't need to worry about that. But essentially, we're just saying that we want to look at the level, and we want to look at the level at the block below and find out what it is, which we're going to call block below. So if it's air, it will be block below equals air, or if it's ground, it'll be block below equals ground, or whatever. You get the idea. Then we got output, which is that we're going to return back that. Is this making any sense, nor is anyone watching? People are watching, I think. If it doesn't make sense, I can go over anything that doesn't make sense. I don't know. I've never been given the task of explaining this kind of stuff before, which is kind of sad. I wish I'd have been able to do more of this in the past. Hopefully it makes sense. Maybe? I don't know. I'm not getting responses, so I don't know. That's fine. So take things in, where the player is, what the level looks like, do some logic on it, and return it back. So we passed in where the player is and the level, and then from that we're looking one below it, and we're telling the logic for that is that we need to take x, y, x, z is, let's go, and then we're returning that back to the program. And this is the really key part of functional entities, is using that. So we've set up check gravity. It's like, okay, I understand it does a thing. So if we go into scripts, we can actually look at a level. So look at, oh wait, where did I put tutorial level? No, let's look at some real level code, because that'll be a good exercise, probably. If you're going to talk about computer science, you have to look at code. I mean, I know Tom Scott roasted all computer scientists by saying like code doesn't look appealing on camera. If you want to learn about computer science, you have to look at code very quickly, because nothing makes sense without it. Yeah, we can find, can't we? Control F. Please tell me I used that. I must have used that method. Bruh, Python bad. Let me just copy this into a raw text editor. Python bruh moment. Because it should let me just search through for check gravity, but it's being done. I must have used it. Or is there no gravity? There must be gravity. Imagine not coding gravity in your video game. Oh, there's actually no reference to it, bruh. Okay, level 3, that will definitely have reference, right? I hope. Watch it, just, I never use that method ever. That'd be such a bruh moment. Okay, here it is. And then we're using it in our code here. Wait, I can search for it here, I'm being dumb. So then here's our main program. So this is like the key of all of computer science. What you do, set up your logical entity, bundle it into a package that we've called chuck entity, functional entity, bundle it into a package, and you ignore the logic. So you put the things in that you need to put in, and it gives you out the things you need to get out. So here, that entire logic has been summarized by one line of code here. And we call that abstraction because we like to sound fancy, but essentially just means bundle it in a single package. So all of that code there, which is like, how many lines of code is that? Uno, dos, tres, cuatro, cinco, seis, siete, ocho, nueve, diez. I don't know, 11 in Spanish. 11. So we've got 11 lines of code, and we'll summarize it all here in one. So this is the use of that functional entity. So because of object-oriented programming, which we'll get to later, we don't actually have to pass in the data that we need to, but usually you pass it in. So here we'd be passing in where the player is, the player position. And we'd be passing in, what else are we passing in? Oh yeah, what the level looks like. This is usually what the code will look like. It's just because object-oriented weirdness. But you do that, and so you're getting the information you need, and then you're saying put that information in a new thing called block below, which is quite reasonable. And then we can use that in later programs. So then we're going to check, is it air? If so, make them fall. If it's 0, then the player needs to fall out of the world, which is what this is. And if it's smaller than -10, oh, this is reset. So if they fall far enough, so if the block below them is low enough down, then like put them back into the level. So there we go. That's all you need to know about functional entities with an example and stuff. It's a functional entity, you put stuff in, it gets you the stuff out. And you use that over and over again in computer science. You link them in intricate ways. Oh, and the other thing is that there needs to be logic to tell you how you put the things out from the things you get in. And once it's being configured, you can ignore the logic and it becomes just in and out. Let me draw that. So it goes from being like this to you only think about it like this. And you hide away the internals because you can, once it works. I'm going to be using functional entities in next few stuff as well. So that's it really. We're ending the video very soon. I just wanted to talk about the next stuff. So the next bit we're just going to looking at the fundamentals of imperative programming, which is essentially just building on this so we can move into actual programming. And then we're going to look at like hopefully be able to cover all of programming quickly is the idea once you've got the fundamentals down. And then object-oriented programming for 3 or 4 minutes is the next goal. So yeah, that to come. I hope you got something out of it, found it somewhat enjoyable or useful. One or the other maybe. Thank you so much for watching. Hope you have a good evening. See you later, bye. Oh, I'm just going to wait for chat and then I'll end. Is there chat? Anyone chat? Bye. I don't know. It's weird, I've got viewers, I've got 2 viewers, but then no chat. That's okay. Bye guys, see you later.